Okay, this is the lecture on Chapter 3, Section 1, Inertia. All right. This is kind of a review, but it's going to be looked at a little bit different than probably what you're used to looking at. Inertia. Remember, inertia, the tendency of an object in motion to stay in motion, an object at rest to stay at rest. Now, Aristotle was the first one that noticed this, and I have this highlighted here to kind of make it look a little better. So, Aristotle noted that bodies at rest resist being moved, but he failed to link this property to the tendency of an object to keep moving once it was set in motion. So, he noticed when something was sitting still, if you went to push it or to move it, it resisted that change. Okay, it resisted the that movement. You had to really push it to get it moving. Once it started moving, it was moved fairly easy, but getting it to move was the thing. So Aristotle's the first one to notice that. Then, of course, we see Galileo. Okay, Galileo observed that on a flat surface. Oh, remember the sloping boards? We saw it in the movie. Here's an example right down here. Okay, as he was rolling these balls around on these slopes. He observed that on a flat surface, the speed remained nearly constant, and he hypothesized that if the flat surface produced no force on the ball, such as friction, the ball's speed would neither increase nor decrease, but remain constant. All right, that was his hypothesis. Now, um, this is the first case of where we see an actual hypothesis, and Galileo is the first one to actually use the scientific method. So he most likely created it. All right. Um, or he didn't create the steps or anything, but as we look through his papers that he wrote about these things, we noticed he used a method. It was a constant. He would ask the question, research and find information. He would form a hypothesis, and he would do those steps. Although he didn't name the steps, he used those steps. Okay. So he's the one that noticed that if a ball moved at a constant speed on a flat surface, he figured if there was no friction that the ball would remain moving at a constant speed. Then along came Newton, and Newton's the one that changed all this. Newton recognized the special importance of inertia. He described it in what is now called Newton's first law of motion, sometimes referred to simply as the law of inertia. This law can be stated as follows: a body continues in a state of rest or of motion in a straight line at a constant speed unless made to change that state by forces acting on it. And this seems really simple, but as we look at it in astronomy, this is huge. Okay, um, for example, the moon moving around the Earth. The moon should just move in a straight line, but there has to be some kind of a force acting on the moon to keep it in place. Okay. And that force is gravity. But inertia says the moon ought to just keep moving. It doesn't. It stays where it is at around the Earth. So there has to be something holding the moon there. In applying Newton's first law, we should note two important facts. First, we have not identified the force yet, but have relied on our intuitive feeling that a force is anything that pushes or pulls. Second, we need to note that when we use the term force, we are talking about a net force. That is the total of all forces acting on a body. All right. And here is this example of balanced forces. They're both pushing with the same amount of force, so the box is not going to move. Okay. Newton's first law may not sound impressive at first, but it carries an idea that is crucial in astronomy: that if a body is not moving in a straight line at a constant speed, some net force must be acting on it. And again, here you see this girl spinning this ball over her head. And the force here is applied by this string, okay? It's holding the ball in place. And if that force breaks, the string breaks, notice that the ball moves off in a straight line, away. What's in motion stays in motion. What's at rest stays in rest. If there is no force, the object will move in a straight line. So when that string breaks and the force is released, that ball will just move in a straight line. Okay. All right. That's pretty much it. for this. Make sure you read this because it's going to build on this as we go into the next section.